All right, welcome back to another episode of Tech Transfer Insights, where every week we take a look at some technologies that are in the patent portfolios of some of the major American universities. And the first step of every week is finding out which universities we should do. So here's the same Gemini prompt that I've been using for the last few weeks. And we're just going to literally copy this and paste it in here, see what we come up with for the week. Michigan, Clemson, and Ohio State. So let's say we already did Clemson, so we're going to say please select a different second university. Because they did Brown. So how about we'll do Michigan, Washington, and Ohio State. I need to come up with a better way of doing this, is what it seems like. So Michigan, Washington, Ohio State is what we'll work on this week. All right, so first up this week, we have the University of Michigan, and I just realized that I'm using this little where this picture-in-picture pop-up and it was blocking some of the interesting stuff. So I'll move that over here. All right. In full disclosure, both my dad and my brother have degrees from the University of Michigan, but I myself do not. So my family has some connection to this university, but I don't. Um, this was an interesting one because it ties back into one of the things that I think is important to remember, which is the I'll say extractive industries are still a thing. Sure. So, for example, oil and gas and like mining are still very, very common industries, and they make a lot of money, and they are able to support technologies very effectively if they solve a problem for them. So, you'll see a lot of times that universities have these technologies that are sort of associated with extractive industries that are available, but a lot of people don't seem as interested in them because they view it as not environmentally friendly or something like that. But ultimately, we still need resources from the earth, at least for the foreseeable future. And in order to utilize them, we might as well make it more effective to uh, and more environmentally friendly to get stuff out of the ground. So this particular technology is a way of communicating sensor data, it seems, through a borehole using mud as a transmission line, uh, which is interesting. So, from what I can tell, and granted, this is another one of these examples of like it has very complicated language, single conductor transmission line, and the design. Like, what does that title mean? I have no idea. But basically, what it seems to be is a communication device that takes data from the end of the exploratory drill bit and sends it back up the borehole that it is drilling and collects data from the various sensors and motors and actuators on the drill bit itself using suffer from a variety of functionally limiting issues, low transmission data rates, and I can certainly understand that, right? So this apparently solves that problem. Um, Overall makes a lot of sense, I think. And I can certainly believe that that is a problem with existing technologies for communicating down boreholes. What, the technical description here is, I think, you know, not particularly understandable. I don't know what lambda is in this context, uh, but it seems to, again, solve a very noticeable problem and be in an industry that can very much support technologies that solve these kinds of problems. It also has a patent, which I thought was kind of cool. So the inventors here, I'm not sure where exactly or what do you call it, school or department they're from, but they have a very clearly defined patent application that was active since 2019. And it has all of the different descriptions in here of like a transducer and a helical conductor, so you can dig into some of the patent stuff. But basically, this is an interesting idea that could end up being a specialized technology that solves a problem for a very important industry. And it seems like it's self-contained enough that it could make a good startup as well. So, next up, we have the University of Washington. I'll say that was a little bit harder than I was kind of expecting it to be. But this is University of Washington's technology that I think I found interesting. Again, in full disclosure, I've done a project with Washington before. It was not anything to do with this one, but that was a few years ago at this point. And lately, I have not talked to them, so again, have no real affiliation. But I feel like I should say that up front. Uh, that being said, this goes back to another one of these, we'll call it overlapping things in life. So my one of my other, I'll call it projects, is writing for a space exploration blog. Uh, and one of the things that I have written about recently was a pulse plasma thruster, which is a propulsion technique that small satellites can use to go pretty fast. And when I saw this, I was like, huh, that's an interesting idea. So it's a combination of a ramjet or something equivalent to that, where it sucks up the atmosphere surrounding the in this case a satellite, I guess, and turns that into a pulsed plasma for use in uh, pushing the satellite forward. What that basically means is that the satellite itself would not have to carry its own propellant and could theoretically be kept aloft at the upper reaches of the atmosphere indefinitely. That's obviously a problem that a lot of, we call it older satellites, fall prey to, is the problem that they run out of fuel and they have to be deorbited and all this kind of stuff. So this would essentially solve that issue. Um, but it's also not the only technology doing this. Like scooped plasma, there's scooped atmosphere plasma thrusters are not completely uncommon, but apparently this one has some solutions over existing ones that focus on its ability to utilize uh, the atmosphere no matter what the pressure variability is. Uh, there's some, what it says, novel electrode placements, anode and cathode placements, not electrode placements. I guess it is variable electrode spacing that allows it to operate no matter what the density of the atmosphere is. So, with that being said, a propulsion system that would allow a satellite to stay aloft indefinitely is definitely of interest to a lot of satellite manufacturers. And I can see if this would solve a problem, and it certainly seems like it does, and hopefully or potentially better than existing other air-breathing plasma thrusters. This could be potentially game changing for the satellite industry, allowing some satellites to stay aloft at relatively high altitudes indefinitely. So, there is a patent. It came out in 2019, I believe. Yeah. So, public era, it was accepted in 2019, going from 2021. So, it has an expiration date in 2040, but has some really nice little diagrams here of what this thing would look like. That's a pretty looking thruster. Uh, so, if you're interested in the air breathing plasma thruster with variable spacing cathode to help satellites stay aloft indefinitely, you can reach out to CoMotion at the University of Washington. I know from experience that they are extraordinarily helpful. So, next up, we have Ohio State. All right, it is time for a technology from the Ohio State University. And I always think it's funny. that they use the. It's also kind of ironic that we're doing both Michigan and OSU this week. So again, I once again for the third time this week have to give another disclosure. I worked on a project with OSU for 5 plus years, relatively recently, and just stepped away from it within the last year. OSU is one of the larger universities in my home state of Ohio. It's about 2 hours away from me. I know the campus and the technology managers here particularly well. So again, I don't think I'm unbiased necessarily. I do have a lot of insights and thoughts on OSU's licensing process, but here is not the time to discuss that. So I did want to take a look at another novel technology here. I'm a sucker for sensors. I think I talked about that before at some point. And this was an interesting one. So, one of the other things that I do is invest in real estate, and I know that mold is an especially pernicious, that's a fun word, problem in some parts of the country. So, normally you'd have a building inspector go in and like look and say, oh, look, there's mold here. Physically, they have to either see it or smell it, or just know that it's wet. But a system that can quantify the presence of mold, especially apparently dangerous types of mold, is a very interesting idea. So, this is a quantitative measurement tool needed to assess the growth of a species of fungi and potential adverse health outcomes. So, this sensor basically detects whether there's any type of mold in a general area. And I think that's different than most other tests that are species specific molds, I think is what it says back down here somewhere. Uh, Generic measurements are more precise and objective than observation. Genetic measurements. Oh, it's a genetic test. Okay. The current method detects specific mold species, and it detects mold before they become severe or cause symptoms like asthma, I think they mentioned above. Overall makes a ton of sense. I don't know if there are competing technologies or not, but I thought this one was interesting because of the viability of the sensor to solve a very specific problem that I personally know is a problem. And once again, has interesting applications uh, in a growing field, I guess is the way I would put it. So, you know, relatively simple to understand in this one. If it works and solves a particular problem, then sounds like this is a pretty easy selling point for this technology. And if you're interested in learning more about a sensor that can detect all given mold species, they say there's a PCT file. I'm guessing if you look up the inventor's names, you can probably find that, or you can reach out to the licensing manager here at OSU. But I think that is it for this week. So, with Michigan, Washington, and Ohio State under our belts, I'm going to call the seventh edition of Tech Transfer Insights complete. If you guys have any comments or suggestions on how we could do better or ideas on how you would use these technologies or other particular technologies you would want me to take a look at, feel free to leave a comment down below and I'll do the YouTuber thing and say please like and subscribe if you haven't already. Other than that, I hope you guys enjoy your week and I'll be back next week with some more interesting technologies to take a look at. Thanks a lot, and I'll see you later.